Hello and welcome back to our data structures and algorithm series. In this video, we continue with our journey in recursion by tackling the Fibonacci sequence using Python. Remember, recursion is a technique where a function calls itself to solve smaller parts of a problem, and the Fibonacci series is a perfect example of such a problem. Let's begin by understanding what the Fibonacci series is. So, by definition, it is a sequence of numbers that begin with a 0 and a 1. Thereafter, it increases steadily, where each number is equal to the sum of the preceding two numbers. So here's an example that I have. So here we have the starting point, the beginning, which is by default the 0 and the 1. Now the Fibonacci of a number is also written as f. Let me just use capital so that it can be more visible. F of n, like that. So here the Fibonacci of 0 is actually f of 0, but it's not the number 0. F of 0. What is 0 looks like? Oh, okay. So that is f of 0, but n is not the number 0. It's actually the position of the number. So on the other hand, the next Fibonacci here is f of position 1. So position 0 and then position 1. Then this will be f of, yes, you get it right, that will be position 2. Then this will be f of position 3, and so on and so forth. So what we are saying here is that f of 0 is 0. F of 1 is 1. And that is a rule. Now going forward, for example, f of 2 here, let me just write it. So f of 2, which is position 2 and not the number 2, f of 2 will be the sum of the preceding two digits. So we can see here that this is what we want, f of 2. So the sum of the preceding digits will be 0 plus 1. So if you look into that, then what we simply mean here is that this will be, let me get that back, this will be f of 0 plus f of 1. Similarly, if we want to calculate f of 3 here, f of 3, so that will be f of 3, like that, is equals to f of the two preceding numbers. So we have f of 2 plus f of 1. So those are the two preceding numbers. So if you add 1 plus 1, then you get the results, which is 2. Similarly, the number 3 here, that particular position is f of what? Yes, you guessed it right. That is f of 4. So how do we calculate f of 4? Let's do it here. So that will be f of 4, like that, is equals to f of 3 plus f of 2, like that. So that's how we get the number 3, because 1 plus 2 is equals to 3, and so on and so forth. So I hope you can already get what we are looking for here. We are looking for what? We are looking for the recursive function. So this is exactly what we call the recursive function of a Fibonacci series or Fibonacci sequence. So if you can see here, then we are simply coming up with this particular function, that f of a position n then will be equal to f of n minus 1, where n is the position, plus f of n minus 2. So this is our recursive function, the recursive function. Remember, that is the step number 1, finding the recursive function. So this is the recursive function. This is the recursive function of a Fibonacci sequence or series. So let me just show you that again using this animation that I did. So in order to get 1 here, then we get f of 0 plus f of 1. In order to get these two here, we do f, the two preceding numbers. So f of 1, f of 2 plus f of 1, like that. In order to get the next one, then we do the two previous numbers, so that will be f of 3 plus f of 1. So that is how we do it. That is how we find the Fibonacci series. So let's jump right in and write a code using Python in VS Code. So let's create a new file here. I'll call it Fibonacci.py. So we need to find, we need to create the function. So Fibonacci, then we can pass it a number. So remember to put the full colon there. And then we need to find the unintended case, unintended case. So again, as I mentioned here, oh, keep on making this mistake. This is supposed to be a hash. Okay, so as I mentioned here, the default values for the starting values for a Fibonacci sequence is a 0 and a 1. So that tells you we cannot have anything less than 0, right? And it means also we cannot have any number less than 1. So again, here we can use the assert function. So we can do assert and then num should be greater than 0. So num should be greater than or equal to 0, because you can also have a 0. And num should be an integer. So int num should be equal to num. Then after that, we'll do a comma and do the error message. So the number should be a positive whole number. So that's the error message. The next thing we should find then is the we should find the base case. So the base case. So the base case should be when we get to either a 0 or a 1. So we can do if num in then we do a list. So 0 or 1. So if it's there, then we want to return 1, because those two starting values will always give us a 1. Else, we now want to do the recursive case. So this will be return. Fibonacci num minus 2 or minus 1. We can start with that. Then plus Fibonacci num minus 2. like that. So with that, I think we are done. I did a mistake here. I put a semicolon. It's optional in Python. Sometimes it can allow you to do that. But for conventions, you have to stick to one. It's either you're using them or not. So let's not use them. So we can do results. Then we can call the function Fibonacci. And for example, let's find the Fibonacci of 2 and print the results. So print results. Okay, so let's see how this goes. I'll right click and click on run in terminal. Okay, so the Fibonacci of position 2 is 2. That is what it's giving us. So let's just confirm that. So position 0, position 1, position 2. So that is not correct. So we got a wrong answer there. So the Fibonacci of 2 is supposed to be 1, but we are getting 2. I found out the problem was because here we are returning 1. So 2 minus 2 is going to be 0. And when it's 0, it's supposed to return 0 rather than to return 1. So it's actually adding 1 plus the Fibonacci of 2 minus 1 again is 1. So we are adding 1 plus 1. So that's how we are getting 2. So we're just supposed to correct this so that instead of returning 1, we return the number. So if it's 0, we return 0. If it's 1, we return 1. So this function call is going to do 2 minus 1, which is going to return 1. This one is going to do 2 minus 2, which is going to return 0. So 1 plus 0 is what is going to give us the correct answer. So if we run this again, then now we have the correct answer, which is 2. We can test this again, maybe with a 3. 3. Okay. And we get 2, which is the correct answer. If we run 4, we get 3, which again is the correct answer. So thank you very much. Thank you very much. We are done with this part of calculating the Fibonacci of a number. I hope you've learned. Let me know how you feel we are moving on the comments, and I'll really appreciate it. In the next video, we will look at one more challenge, then I'll give you a few exercises which you can try out. Thank you so much and see you in the next video. Bye.